We're back on site here at Parc Eirin in the Rhondda Valley to look at the first fix of the property behind us. Now, keen viewers will already spot there is one major significant difference on this property, and it is supplied by three-phase power. And to help us understand the thinking behind this, I've got Kian here from Western Power. So why have Western Power decided to go for three-phase as standard on new build properties?
Well, I think as we can see with these properties here, we've got low carbon technologies all throughout, heat pumps, battery storage, electric vehicle chargers. And as we know from the government's plans and strategies, that's the way we're going. So for us, we need to make sure that our customers are ready to decarbonise as and when they can. So by offering three-phase supplies, we can ensure that the power is there sort of as and when our customers need it. Yeah.
Okay, so you're quite unique in terms of network operators, because the other ones we've seen, you might be lucky and you might just get a slightly thicker supply cable. So what really drove the internal thinking on the three-phase instead of just offering thicker cable?
Well, I think with three phases, by offering the three separate phases, what we can do, we can keep the network balanced and offer 400 volts, 300 amps if necessary, and we can also roll that phase throughout whatever housing estate that we've got to keep it balanced, reduce losses on the network, and that in turn then is better for our customers and our network as well.
Okay, now this property here we've already looked at in the first video, and I'll put a link in the description for that. We've got three-phase EV chargers on these properties, and we've never seen them deployed at scale like we have on this estate. They're all three-phase, so everyone can charge at 22 kilowatts, which is fantastic for anyone who does lots of miles, I can tell you. The rest of the property, and this intrigued us, is how that is managed, that three-phase. So everything is single-phase equipment, but split across the different phases. But from what we've seen, the hob is always, say, on L2. How are you ensuring that that balance, you know, at tea time when everybody's trying to cook, is maintained across the three phases?
So yeah, for us it was important to work with Sero on this project and sort of understand how best we could sort of set these houses up and wire them up to make it as easy as possible. As I mentioned, we want to make sure the network is balanced. So by keeping everything in-house on the same phases and by rolling it at the meter here, we can make sure that we balance the network throughout the housing estate. And as I mentioned, the losses are reduced and it's much better for our network and customers as well.
Yeah, so in the future, you know, if I want a 20, say I'm not in one of these fantastic new homes and I want a 22 kilowatt charger at home, is that possible to get that supply upgraded?
Yeah, well, Western Power distribution, subject to qualifying for it, as you mentioned, sort of installing a low carbon technology that meets the requirements, then yes, we will look to install or upgrade your single phase supply to a three-phase supply, so that, as I mentioned earlier, our customers can decarbonise as and when they need to, whether that be with a 22 kilowatt charger or a heat pump and so on.
Yeah, so really you are ahead of the other DNOs, you're future-proofing your network to go and see how Gary's getting on with the rest of the first fix.
We saw in our previous video the consumer unit, well it wasn't, it was a distribution board in a two-bed dwelling. I've got one very similar, okay, the layout is exactly the same, just the configuration is slightly different. I'm going to take a closer look at what's going on inside here, but already you can say to yourself, this isn't our standard domestic dwelling fuse board, and there's a lot more going on inside it. So let's take a closer look. Start with the means of isolation here, three-phase and neutral main switch, and in these installations, as we've seen where Gordon's been at the mains end, we've got a steel wire armoured cable from there feeding the distribution board. We said in a previous video it's essential that we have surge, type 2 surge protection device installed. We know with the amount of electronic equipment in here, the last thing we want is that spike and therefore causing damage to those devices. I'm sure we could do a risk assessment and remove the need for that, but for me it's essential it's in here. So from this section here, as we saw previously, these circuits here feed the railed system above us, and this means that we've got a standard configuration pretty much across all the properties here, where we're using obviously our three phases, our L1, L2 and L3, feeding up to circuits at the top here on the rail system. Now it might be that every single lighting circuit is on L1, the brown phase, and what they do is they mix it in the actual cutout or where the metering is. They rotate their phases there, so we don't have all properties having the hob, say on L2, because obviously that wouldn't balance it from the point of Western Power. When we talk about metering, as we did before at the bottom of the panel, so we come down and look at the metering sections here, we take a deep dive into the meter, and it's not just the overall power consumption from the kilowatt hour meter that Gordon's got at his end, that we're actually breaking down each element of the system so we can forensically measure the power, say, for the ground source heat pump on its own. We could look at, say, the energy from the regulated and unregulated loads. And we said that regulated loads were things that we knew were fixed values, the lighting, the immersion heater, and unregulated loads were things like the socket outlets, because obviously we could plug in at different times in different loads. Nice to see, and also almost essential now, is it, individual RCD protections for circuits. So we've got these eFIXX AFDDs, RCBOs for some of the circuits. Not all of them are protected by AFDDs, but if we look here, this one is the RCBO AFDD type. It's also an A-type RCD. It's rated at 30 milliamps, so it offers obviously our additional protection as well. We've got our standard A-type RCDs as well for some of the other circuits. The panel might have come pre-configured from eFIXX, but we can already see that this is a significant step up from standard consumer units in domestic dwellings. And with that step up, obviously the electrician's knowledge has got to follow that as well.
So let's have a look at the first fixed wiring, where that enormous distribution board is going to end up in this cupboard here. So here's our incoming supply from the meter box outside. It's a 25mm 4-core armoured cable. There's a separate CPC for that. There's another armour cable that goes out for our EV charge point. And then here's the conventional wiring for the house. So there's the usual things we'd expect to find: the ring main, the lighting circuit, the supply to the hob. Interestingly, on this property, this is all in low smoke and fume cable. So we see the white twin and earth here. But then the striking difference with this property is when it comes to data wiring. So we've got actually two data networks. There's one for the customer, so that's, so you can have the your Wi-Fi router and obviously your smart TV plugged into a data network. And then there's a completely separate data network that we've got in these purple cables here that go out to the harvest the data from the low carbon technology. So there's one for the battery system, there's one for the smart hot water cylinder, there's a separate one for the metering associated with the hot water cylinder, another one for the ground source heat pump. So lots of data, and let's not forget one out to that EV charger, because they all obviously have to be smart. That data network sits completely separate to the one that's supplying the customer's house, and that gets its data input from this fibre optic cable here that connects up with all the properties. So again, all the properties on this estate can work in unison as part of a smart grid system. The control box is already in for the brains of the operation that we saw. Again, we don't look in there because that's all hush-hush what's actually going on in there. And then our thermostats, the last thing there is a separate RS-485 network where they're all, again, wired in a series bus, again, back into that box to do the control for the heating. And finally, under the stairs, so we're looking for the shoe box, and here's the space where the shoe box will go. Here's our supply to our ground source heat pump, and there's the flow and return from the system, which again is buried deep underground, outside and shared between a number of properties.
As I walk around this installation, there's lots of elements of the circuitry that I could install comfortably, and there's elements that I'd find really challenging at the moment. I'm joined by Dan from Sero. What's your role within the company, Dan?
So currently I install and commission the Sero system inside new builds, and I also oversee the installations of the Sero system for retrofitting.
Okay, so that sounds really complicated. What's your background?
So my background is plumbing and heating. I worked as a plumber for 9 years. And then I saw the opportunity to sort of get ahead of the game when all the gas started being phased out. So from there then, I joined Sero and did a bit of upskilling.
Okay, so I think there, it's grasped the words there, saw the opportunity and decided to change your skill set. So you've still got your gas background, and you've now effectively controlling this system. The bit that maybe the electrician would find difficult or uncomfortable with, maybe from their current skill sets. Is it a challenge you think is worth taking on?
100%. The way housing is going, this stuff's going to be coming in thick and fast. I mean, if I, as a plumber, can pick up the installations within 11 months and be comfortable supervising people doing it, then any electrician, if they put their mind to it, will find it easy.
Now, I never thought I'd see a 2-bed semi with a 3-phase supply going into it any more than I'd hear a plumber as retrained and reskilled in order to install electrical systems.
Yeah, now let's just reiterate that. Plumber retraining as an electrician because of the opportunity. Now, all the time we hear plumbers make all the money, but now it has flipped over. The electrification of heat, transport is a tremendous opportunity. In our previous video, we saw how this whole house works together as a smart energy system. We've now seen the first fix. In the next video, we're going to look at how all of the houses on this estate are one huge energy asset and how that's controlled.
As always, we're interested in your feedbacks and your comments. What did you spot on that first fix as we walked around? What questions you got for us? Leave them in the comments below and we'll get back to as many as we can.